Is it still St. Patty's Day? I believe it is. Have you ever used that thing where you use a compass and maybe try to find where you are? Do you remember what it's called? It's got a lot of places and streets on it. It's called a mop. And that's how the Irish say it, a mop, especially if you're in Dublin. Or you might be in Northern Ireland. Northern Ireland talks a little bit different. They say they're from Belfast, and they talk really fast. Have you been to Belfast? I can't do it very well, but I keep trying. So this is where we finished off last time doing the 6 trigonometric functions. Now we're going to try solving just for an individual one. So use the given triangle to find the following trigonometric functions and ratios. Fill in the angle measured in side lengths on the triangle. So what is cotangent of 60 degrees? Well, we go ahead and draw a right triangle. We always draw that triangle. I hope you're not sick of the triangle yet, but we keep drawing it, don't we? So don't forget 60 is the bigger angle. And that means that 30 degrees, we want to rotate this. It'd be more fun if we rotated it, wouldn't it? I think that looks prettier, don't you? There we go. So 60 degrees is a special triangle. And what that means is that we have a long leg and a short leg and a hypotenuse. Across from the 30 degrees is the short leg. Across from the 60 degrees is called the long leg. And across from the 90 degrees is called the hypotenuse. So do you remember what cotangent is? If tangent is opposite over adjacent, what's cotangent? So cotangent then. Cotangent is adjacent over opposite. Well, that's interesting because they didn't give us a number about any side lengths. So we're just going to assume the most reduced one. And that's the unit circle, which is 1. So we're going to say our short leg is equal to 1. Or no, we're going to say our hypotenuse is equal to 1. And if our hypotenuse is equal to 1, that means our short leg is equal to 1/2. And if our short leg is equal to 1/2, that means our long leg is going to be radical 3 times that. So that's going to be 1/2 times a special radical 3. So now we have radical 3 over 2 for the long leg. And if our adjacent side is 1/2, and our opposite side is radical 3 over 2, we're going to get a crazy answer, aren't we? We're going to have to reduce those 2's. And that's going to leave us with 1 over radical 3. I'm doing the most difficult one. What am I doing? That's number 18. You're very lucky there. So you're going to have to go ahead and times it now by radical 3 over radical 3. And that's going to give us radical 3 over 3 times 3 is 9. And the square root of 9 is just 3. Final answer. Radical 3 over 3 is our answer. If you don't believe me, you can plug it in your calculator. So that's 1 divided by tangent of 60 degrees. And that's 0.577, which, would you know, is the same as radical 3 over 3. Make sure you go out of the radical, though, divided by regular 3. Look at that. They're the same answer. That means we figured it out. We're amazing. I think I'm starting to lose. No, stop. Don't keep trying, Newell. Don't give up. I don't know. It's been a long day. Just keep trying. Okay, so number 1 is cosecant. Which one's cosecant? Do you remember? So cosecant is opposite letter. What's opposite of C? Opposite of C is S, so it must be 1 over sine of 30 degrees. So if we find sine of 30 degrees, then we can just go 1 over that. So we'll draw a right triangle now. And we'll say this is 30 degrees. That means this is the opposite side, and this is 60. And this is the adjacent side. And this, of course, is the hypotenuse. Now, in a unit circle, the most reduced hypotenuse is a unit circle of 1, radius of 1. So if we drew a circle around this triangle, be a radius of 1. So we're going to use a radius of 1. We're going to use radius of 1. So if the hypotenuse is 1, then we go from the hypotenuse to the short leg. And we're just going to go ahead and divide by 2. That'll cut it in half. And then again, the adjacent side in this particular problem is going to be from the short leg to the long leg. And the short leg to the long leg is going to be timesing by radical 3. So that'll become radical 3. That'll be 1/2 times radical 3 again, which is radical 3 over 2. And that's what the adjacent side is. So I think we can do cosecant now. So 30 degrees. So what is sine? So sine is equal to what? Do you remember? It's equal to opposite over hypotenuse. So opposite is going to be, of 30 degrees, is going to be 1/2. Divided by hypotenuse, which is just going to be a 1. So this is just going to equal 1/2 over 1, which is just 1/2, is our answer. If you're not sure, you can plug it into your calculator and double check. So cosecant is just 1 over sine. And we're going to do 1 over sine of 30 degrees. And when we do that, we get 2. So I made a mistake somewhere. I thought opposite was 1/2. Oh yes, I remember now. So we just figured out what sine is. Sine of 30 degrees is 1/2. But we have to do 1 over that. So that's actually 1 over that. So that means that cosecant of 30 degrees is actually 1 over 1/2. And that's going to keep change flip. That's going to keep change flip and become just 2. So the correct answer for number 17 is 2 for sure. So cosecant of 30 degrees is equal to 2. So we already did number 18. We're going to let you try 20 on your own, but I'll go ahead and help you with number 19 now. And number 19, this is 60 degrees, and this is 30 degrees. Since we're doing 60 degrees, that means opposite is now down below and not to the right. From our 60 degrees for number 19. So now this is opposite, and this is adjacent, and this is hypotenuse. And we're going to assume the hypotenuse is 1. You could use other numbers. They just have to reduce in the end. So now we want to find cosine of 60 degrees. So that's just adjacent over hypotenuse. And so that's going to be the adjacent side. But since this is a 30, 60, 90 special 30, 60, 90. And that means you take the hypotenuse and you divide it by 2. So that's going to be 1 divided by 2. It's just going to be 1/2. And so now we have the adjacent and the hypotenuse. So 60 degrees. So adjacent from 60 degrees is going to be 1/2. Over the hypotenuse is just 1. So it should just be 1/2. Let's plug in our calculator and double check our answer. So make sure your mode is in degrees. And that's not correct, Mr. Newbold, because you typed in the wrong thing. It was cosine of 60 degrees, which is just 0.5 or 1/2. So then we got it right. So again, we were just practicing cosine of 60 degrees. And we got 0.5, which is 1/2. So now you're going to try cotangent, which is just 1 over tangent. So if you find what tangent is for 30 degrees, then you'll be able to use and do cotangent. Find the exact values for the unknown variables for number 21, 22, and 23. So these are all special right triangles, 30, 60, 90. So I should really let you practice them all on your own. So I'm going to wait for a moment while you practice on your own. R they call the hypotenuse. Doesn't matter, it's okay. So what do we do now? What do you think? We want to find y and r. Could you set up a trigonometric function to help? Or can you just remember how to do it because it's a 30, 60, 90 right triangle? So if this is 60 degrees, That means that this is the long leg. And you're going to go from the long leg to the short leg. Do you remember if you multiply or divide when you're going from bigger to smaller? If you're going from bigger to smaller, you divide, of course. So you're going to take the 105 and you're going to divide it by something. Do you remember what that special thing is for the long leg to the short leg? It's radical 3. Radical 3. So you're going to divide by radical 3, but you can't have radical 3 in the bottom, can you? So you're going to have to go ahead and times it now. You're going to have to go ahead and times it. And so you're going to times it by radical 3 in the top. You're going to use a shortcut. And here's the shortcut. You just bring it up to the top, so you get 105 times radical 3 divided by 3. Drop the radical. So that's going to be what y equals now. So y is equal to 105 radical 3 over 3. And now we're going to go from the short leg to the hypotenuse. Do you remember what you do there? So it's double. So you're just going to times it, the whole thing, the short leg, times it by 2. Times it by 2. So we're going from the short leg to the hypotenuse. And short leg to the hypotenuse, you times by 2. So now we have 105 radical 3 divided by 3. And you're going to times it by 2, which you'll just do with the 105. So that just becomes 210. Radical 3 over 3 is our answer. And so that's what r equals. That was a very tricky one. Hope the next one's easier for you. So do you remember how to do number 23 now? Should I pause? Can you do number 10 on your own? 23 on your own with the hypotenuse of 10, I mean. So what you do? What do you think? It's a 45, 45, 90 right triangle. What do you do on a 45, 45, 90? Do you remember? If it's a 45, 45, 90 right triangle, well, the legs are the same. They equal each other. But what about when you're going to the hypotenuse? Do you remember what you times by? Let's say the leg is, so you just take that leg, so the hypotenuse is equal to the leg times a special number. And that special number is that special. We're going to do rainbow pen for you, for your pot of gold. And so you're just going to times it by radical 2. So radical 2 is the key feature there. You're just going to times it by radical 2. You're just going to times it there. You're just going to times it by radical 2. Do you know how to do that? It's going to be a secret now. It's going to disappear. So you better make sure you get it quick. So to go from the leg to the hypotenuse, you're just going to times by radical 2. And if you're going the other way from the hypotenuse back to the leg, then you're going to divide by radical 2. You better write it down quick because it's going to erase in a moment. Write it down because it's a secret. It's a secret going from the hypotenuse to the leg that you divide by radical 2. So we're just going to take our 10 and we're going to divide by radical 2 to get the x and the y. So that's 10 divided by radical 2. It's going to disappear. Whoa, something weird happened and I don't know what to do. I'm confused. It's all confuzzled. Let's stop using the magic pen there. Okay, so you just take the 10 and you divide it by radical 2. But you can't have a radical in the bottom. So that means you bring it up to the top and you get 10 times radical 2 over. Get rid of the radical. Get rid of the radical. Just a 2. And 10 divided by 2. 10 divided by 2 is 5. So you get 5 radical 2. So that means that y is equal to 5 radical 2. And x is also equal to 5 radical 2 as our two answers. Did you get that right on your own? Pat yourself on the back, Patty. Did you get that, St. Patrick? Did you get that? Pat yourself on the back. So try number 24 on your own with a zip line. You're going to be using, remember if the sides are the same, If the sides are the same, then the angles are the same. What do the angles have to be then? It's going to be special. It's going to be a special angle. There's your hint for number 24. Number 25, use sine, cosine, tangent to find the unknown side. So now you're going to have to identify from the angle which one is opposite, adjacent, hypotenuse. Always across from the given angle is the opposite side. So we call it OPP. Across from the 90 degrees is always called the hypotenuse. That means this must be the adjacent side. So now here's the formula. Here's the formula. So the formula is going to be trig of the angle. So trig function of the angle is equal to some side over some side. That's the formula. Is it sine, cosine, tangent for your trig? It's going to be one of them. Well, you got to identify what they've given to you. They've given you the adjacent side. So it might be tangent or it might be cosine. But they want you to find the hypotenuse sine. So you're not going to have to worry about opposite. You're not going to have to worry about sine. Do we know what adjacent hypotenuse is? That's going to be cosine. So now we use the angle they give us. So it's going to be cosine of 39 degrees is equal to the adjacent side over the hypotenuse. The adjacent side they give us is 44. The hypotenuse we don't know. We're calling it G. So now we just got to solve for G. We're going to multiply it over to the other side. So we're going to multiply it over to the other side because we're trying to solve for G. Then we're going to have to divide the cosine 39 to the other side. We're going to divide that to the other side like so. So now we have G is equal to 44 divided by cosine 39. And now we're just going to plug that into our calculator. So 44 divided by cosine of the angle 39 is going to give us something special. 56.617 round to 2 decimal places. So now we got 56.62 technically. 56.617. We want to round in centimeters. We want to round to 2 decimal places. So that 7 is going to round the 1. It's going to be rounded up to a 2. So that means that G is equal to 56.62 centimeters. That's just the bell for class to start. Lunchtime's over. You got to come back to class now. Okay, we're going to finish off. We're almost done. Go to the last page. So you got a 5-foot wall ladder leaning against a wall. We want you to try it on your own. What is the angle between the ladder and the wall? So they're asking for theta right there. What's that angle? So you've got your ladder. They want to know what that angle is. And all they give you is they do give you the ladder. And they do give you the floor. And since we're talking about the angle there, they don't even give you this side. So we won't worry about it. But they do give you that this is a right angle, right triangle. And so that means that this is the hypotenuse. And that means this is the adjacent side. But they don't give you the opposite side. They don't even ask for it. So what is adjacent hypotenuse? Do you remember? Do you remember what trig function is it? Adjacent over hypotenuse. It's cosine. So we're going to do cosine of some angle is equal to the adjacent side, 2.5, over the hypotenuse, 5. Now how do you undo cosine to get the angle? You got to get rid of that cosine. So if you do the inverse function of cosine, it'll get rid of it. But you have to do it to the other side as well. So now we're going to do the inverse. Now we're going to do the inverse cosine of 2.5 divided by 5. That will give us our answer. That's going to be 60 degrees. Look at that. We found our answer. You found it. 60 degrees. You're amazing. So you try number 28 on your own now. And 30 as well. 31. Charlotte is enjoying a sunny day in the garden on top of her apartment building. She hears a siren and is curious where it's coming from. She looks over the edge of the roof and spots an ambulance at the park down from the street in her apartment. So here's Charlotte way up here. She's waving to you. The angle of depression to the ambulance is 3.4 degrees and her apartment building is 40 feet tall. That's not a very big angle. Don't know if I believe it. So the angle of depression means we're going down. So draw a picture to help you solve the problem. Round your answer. How far away is the ambulance from the front door of her apartment? So we're just talking about this side right here. So we want to know that distance. Well, this is a right triangle, an angle of depression. And so that means we're going to be looking at that side. So that side from the angle is going to be the opposite side. And that means that this is the adjacent side. So which trig function goes with opposite and adjacent? So we're going to go tangent of 3.4 is equal to opposite over adjacent. And that's x over 3.4. No, that's x over 40 because it's opposite over adjacent. So you're simply just going to multiply that 40 to the other side and plug it in your calculator. Now we're just going to plug that into our calculator and wish upon a star. So 40 times tangent of our angle 3.4 is going to give us approximately 2.376, which doesn't seem right, but we'll go for it. There we go. So that's 2.376. Round your answer to the nearest tenth. That's going to round up to 2.4. And that's going to be 2.4 feet. That doesn't seem very far. Maybe the building isn't as tall as you think. But that's what we're going to give you here. I'm seeing something else different. So we'll have to take a look and come back to this video. Thanks for watching. Talk to you soon.
I don't know if you still talk to him.
All right, I think I figured it out. With my help of my statistics students. Woo! Yeah. If anybody wants to shout out yay and be immortalized on my video, you can. 3, 2, 1. Nay. Oh. Okay. So angle of depression is going down, but I think it's actually not this way at all. I think it's looking this way is our angle of depression. So it's looking across but also down. And then alternate interior angles are congruent because this is parallel to this. So that means that 3.4 would also be 3.4 down here. And then across from that angle would then be 40 over x. So this is actually going to switch. So it's going to be 40 over x is what we're looking at, I think. So 40 over x is opposite. So that's wrong. Opposite over adjacent. There we go. So then we have to multiply x over to this side. And then divide by tangent 3.4. 3.4 is still a really small number, but whatever. So then we divide that over to this side, and I think that gives us our correct answer according to what we really want for angle of depression, I guess. And so that's 40 divided by tangent 3.4, which is 673 feet away. That's really far away. So 673.27. Round your answers to the nearest tenth. So that's going to be 673.3. So x equals 673.2 whatever, 3. And so that is going to be to the nearest tenth for feet. Is our answer? Cool. So angle of depression goes across and down, and then you do alternate interior angles, basically. So that was a crazy one. And then our last one is going to be number 31. So which of the following would be an equation representing the relationship between the angle measurement, W, the side measurement of x, and the diagonal measurement, y, in feet? Well, this is a right triangle. So that's going to be opposite over hypotenuse. And which trig function is opposite over hypotenuse? So that would be sine of W is equal to opposite x over hypotenuse y. Can we find it? What the? Is it that one? Sine of W equals x over y. Well, and that's going to be letter I, which is what we got. Okay, thanks for watching, and happy St. Patrick's Day. Woo! Happy St. Patrick's Day to ya.